Okay, so we're going to graph and solve quadratic inequalities. So we'll have single inequalities, we'll have a system of quadratic inequalities, and then we're going to talk about how to solve a quadratic inequality on a number line. Okay, so if I've got it in standard form, remember that to find your vertex, you're going to use this formula, x equals negative b over 2a. And so if I have y is less than 2x squared, it's the same as y is equal to 2x squared, just that inequality is going to tell you two important things on your graph. What does that inequality indicate? So open and closed circle is kind of like a dashed and solid line. So that's kind of like the same in the shading. Okay. So if I've got just 2x squared, can you look at that and tell me what my vertex would be? It would be 0, 0, right? Because standard form is your ax squared plus bx plus c. And if my formula was negative b over 2a, I'm doing a negative 0 over 2 times 2, which is just 0. Well, when I plug that 0 in for my x squared, I've got 2 times 0, so my y is going to be 0. My vertex will be 0, 0. Alright? So remember that you have to have a table if you're going to graph any type of quadratic, whether it's just an equation or an inequality. So we're going to have 0, 0 in the middle of our table. We're going to do our 2 points above, 2 points below. So if I plug in negative 2 for x, that's going to give me what? Negative 2 squared is 4 times 2 would be 8. If I took negative 1, plugged it in, negative 1 squared is 1 times 2 is 2. 1 squared is 1 times 2 is 2. 2 squared is 4 times 2 is 8. Alright. Plot those points. And then we need to look at what type of boundary line do we have. So before I graph it, I'm going to look back at my inequality. My inequality is just less than. So am I going to have a dashed or solid line? Dashed. Because you're doing inequalities, every graph, make that parabola go all the way to the end of the grid so that you're separating, what you're doing is separating two sections. You've got inside the parabola and you've got outside the parabola. You want to visualize it like that, okay? So when we did absolute value inequalities, we did a test point. We don't have to really do that because if you can learn the trick of starting at your vertex, if we start at our vertex, and our inequality is less than, I can go down. So remember, if you're doing a linear inequality, we always say if it's greater than, you shade above. If it's less than, you shade below. Well, that's because you have a specific line. Okay? Here, you're going to start at your vertex. If it's greater than, you go up from your vertex. If it's less than, you're going to go below your vertex. That's going to put you in either inside or outside the parabola. Alright, so this is less than, I go down, so all of this outside area is my solution region. So any point in this shaded area could be true for that inequality. Okay? We good with that? So then, I've got y is greater than or equal to negative x squared minus 2x minus 1 for my next one. So I've got to find the x value of my vertex. So I have negative. My b value is negative 2 all over 2 times my a value is negative 1. So that's going to give me 2 divided by negative 2, which is negative 1. Okay, I'm totally okay with you storing that negative 1 and typing it in your calculator and just telling me what the y value is. Okay? Or you could do it in your head. Either way, when x is equal to 1, what is my y value? So my vertex is negative 1, 0. So you do your 2 points above, 2 points below. And then do all your same steps. Store negative 3 for x. Negative x squared minus 2x minus 1 should give you negative 4. Negative 2 store for x gives you negative 1. 0 is going to give you negative 1. And 1 will give you negative 4. Now, is this one going to be dashed or solid? So extend it all the way down. Okay, and then once you draw your parabola, start at the vertex. My inequality is greater than, so I'm going to shade above or below. Greater than is above, so all of that outside area again. So it doesn't matter where your graph is pointed towards, if it opens up or opens down. All you need to know is once you start at your vertex, you either go up or down, and that falls whichever area, inside or outside. So the direction of opening doesn't affect anything. Okay, so that's when we do one quadratic inequality. Now we're going to do a system. So you're just going to do the exact same thing but twice. Now when you do a system of inequalities, how do I know what my shaded, nope, I just gave y'all the answer. My solution is the overlap shaded region. There you go. Alright, my bad. So, if I have negative x squared plus 3, do I have a b? No, so that means the x value is going to be 0. My y value is going to be 3. So my vertex is 0, 3. If you can't look at that equation and identify your 0, 3, that's okay. Do the formula, okay? Okay, so when x is equal to negative 2, what's my y value? Negative 1. When x is equal to negative 1, my y value should be 2. When x is equal to 1, the y value is still 2. When x is equal to 2, the y value is a negative 1. Okay, for this first inequality, is that going to be dashed or solid? Now, since you're doing a system, I would lightly shade wherever you have to shade. Okay, so it's less than. That means I start at my vertex. Less than means I go down. So that falls inside my parabola. Okay, then for the second inequality, I've got to do my formula. So negative 2 over 2 times 1, which is going to be negative 1. And my y value is going to be what'd you say? Negative 4? Oh, you said it. Alright, so your vertex is negative 1, negative 4. So store -3 for your x. And what do you get for your y? 0. -2 stored for x. So 0 stored for x is -3. 1 stored for x would be 0. Is this going to be dashed or solid? Now this inequality is greater than, so from that vertex, I'm going to go up, and that also falls inside the second parabola. So my overlap shaded region, I'm going to either highlight, shade it darker, draw an arrow, whatever you need to do to indicate that's your solution area. Are you good with that? Okay. So my next problem, I've got x equals negative, what's my b value? -4, and my a is 1/2. So I've got 4 divided by 1, which is just 4. And what's my y value going to be? So my vertex, 4, -3. Now, when you go and build your table, what do I have to be cautious of? This 1/2. Remember, when you have a 1/2 as your a value or any fraction for your a value, you've got to be careful because you're going to end up getting decimals or fractions for every other y value. So remember, whole numbers only in your table. So we're going to have to skip. So if I'm doing 2 points above, what are they going to be? And then 6 and 8. So 0 for x will give me 5 for y. 2 for x will give me, what'd you say, -1? 6 should give me -1, 8 should give me 5. Dashed or solid? It's less than, so from my vertex I go where? Down, so all that outside area. Then I'm going to do the same thing, but for the second inequality. So I've got -2 all over 2 times -1, which is going to give me 1. So my y value is going to be so my vertex is 1, 7. Do I have to skip this one for my x values? No. So when my x is equal to -1, I should get 3. When x is equal to 0, I should get 6. So 2 should give me 6, and 3 should give me 3. Dashed or solid? Now it's less than, so from my vertex I go down. So my overlap shaded region is all right there. Y'all good with that? Okay, so how are we going to solve quadratic inequalities algebraically and graph it on a number line? Okay, so you're going to write and solve the equation by replacing the inequality with the equals, and you're going to solve for those x values. So factoring still, okay? Those x values are going to be called your critical values, which are also called what? Your x-intercepts, okay? So then you've got the number line, and you're going to put your critical values or your x values or your x-intercepts, whatever you want to call them, on that number line, and you're going to do your open or closed circles, okay? Depending on your inequality. So less than, greater than is going to be open. Less than or equal to, greater than or equal to will be closed, okay? So all of that you shouldn't have any trouble with, okay? Once you do that, you're going to look at the sign of your leading coefficient, okay? That sign is what you're going to put on the right side of your inequality, and then you're going to alternate going left. The reason you do the right side instead of starting on the left is because y'all don't know end behaviors yet. That's coming up after Christmas. But your end behaviors, what do you think that says? That's where your graph ends, right? So your leading coefficient actually indicates where your graph is going to end. That's why we start on the right and go backwards, okay? So if my leading coefficient is positive, I'm going to be on the right going positive and then alternating backwards, okay? So around that critical value, you're going to alternate according to the critical value, okay? If you have a double solution, you do not alternate, right? Because every time we talk about a double solution, I draw y'all a graph, right? And what happens with that x value for your double solution? You get one x value, one x-intercept, but remember that all that's happening is it touches it and it bounces back up, right? Or if it opens down, it looks something like that. But either way, you're not changing your sign as far as this doesn't go from negative to positive. This doesn't go from positive to negative. So we're not going to alternate signs if you have a double solution. So writing your double solution and knowing that it does not alternate is going to be important here. Okay? Then you're going to shade it. Okay? So if it is less than or equal to, you shade the negative area. Okay? Because you've already done your alternating plus and minus, right? So if it's less than or equal to, you shade your negatives. If it's greater than or equal to, you shade your positives. To me, that shouldn't be hard to memorize. I feel like if you're doing less than, you're going smaller, those are more negative. If you're doing greater than, you're getting bigger, those are your more positive ones, okay? And then we're going to talk about a few things that we're going to have to write every single problem. So we're going to analyze where it opens, we're going to talk about where it crosses the x-axis, we're going to talk about where it's shaded. So you can use that number line to determine where, if you were to graph it, it would be shaded. All right? So, x squared minus 3x minus 4 is less than 0. So really all we're doing is repeating that equation, making it equal to 0 instead of having an inequality. Then we're going to factor it. Okay, at this point you should be quick at factoring. That's going to factor into what? X plus 1 and x minus 4. It must have equals 0 the whole time, or you're losing points. okay? It's an equation, not an expression, okay? It's got to equal 0 for you to be able to get your x values. Now, at this point, I'm okay if you just tell me, what are my x values? Negative 1 and 4. If you need to do the x plus 1 equals 0 to get the x equals negative 1, then that's fine. Do that, but I'm not going to count off if you don't do that at this point, okay? However, if you forget to change your signs, then that's going to be half your problem wrong, okay? So pay attention to you doing that. So those are my critical values. Now, I've got less than as my inequality. So is that going to be open or closed circles? Open. So I just put open circles and label them negative 1 and 4. Okay. Once I do that, I'm going to look at my leading coefficient, which is positive. So that means my graph is going to end positive. So I'm going to put a plus here. Then I'm going to alternate it. I'm going to have a minus. Then I'm going to alternate it again, and I'm going to have a plus. Okay? These are your x-intercepts if I were to graph it. Okay? This would be in the positive direction. This area would be in the negative direction. This would go back to a positive direction. Okay? So if you need to visualize it, you can. I mean, we know that it opens up, so it's going to look something like this. I don't typically draw that every time, but if you need to visualize it, you can. Okay? Now, it's a less than, so do I shade my positive or negatives? Less than, I'm going more negative, so I'm going to shade my negatives. Okay? So that means if I were to graph this, I would shade in the middle. That's what that's telling me. Okay? So each time, we're going to state where it opens. We're going to state where it crosses the x-axis, so your critical values. We're going to state if it's a dashed or solid boundary line. So open would be dashed, closed would be solid. Okay? You're going to state where it's shaded, and we're going to do the domain. Okay? So domain in interval notation. So here, it opens where? Up, because it's positive. My leading coefficient is positive. It crosses the x-axis at where? Negative 1, 0, and 4, 0. Because those are your x-intercepts. Is it going to be a dashed or solid boundary? A dashed boundary line. And it's shaded in the middle. Now the interval, not the domain, the interval on which it's shaded. Okay? So your solution in interval notation would be, if I'm going on the inside, I'm going from negative 1 to 4. So if you didn't have a graph, you could figure out what x values would fall in your solution area just by doing it on a number line. Okay? So, x squared plus 4x minus 32, we're going to set that equal to 0. That's going to factor into what? X plus 8, x minus 4. So x is going to equal negative 8, and x is going to equal 4. Open or close circles? My leading coefficient was positive, so I start positive and I alternate. It's greater than, so where am I going to shape? Positives. So it opens in what direction? Opens up. It crosses the x-axis at -8, 0, and 4, 0. It's a solid boundary line. Shaded where? Shaded on the outside. So negative infinity to -8 with a bracket, and then your union 4 with a bracket to positive infinity. Okay, do we have questions on that? It just depends if it's open or closed, right? Because your parentheses means not equal. Alright, so then I've got negative x squared minus 4x minus 4 is greater than or equal to 0. I've got a leading coefficient that's negative. No matter what I do, I've got to do what first? I've got to take that negative one out. So I've got negative x squared minus 4x minus 4 equals 0. So if I factor out that negative, that gives me x squared plus 4x plus 4 equals 0. That's going to factor into what? You can either do x plus 2, or x plus 2 squared equals 0. If you recognize that it's a perfect square trinomial, you can jump straight to x plus 2 squared. What does that tell me I'm going to have? A double solution. Alright, so x is equal to -2 double solution. So that means I only have one critical value on my number line at -2. Now my leading coefficient is negative, so I'm going to have a negative, and then remember it's a double solution, so I don't alternate, it stays negative. Okay? So, if this were my graph, we know it opens where? Opens down. So really, some of you might have to draw this to visualize the shaded area, because you're not having your positives or negatives being shaded, right? Here, you've got a greater than. I don't have a positive on my stuff. However, I know that it's equal to this -2, right? If this 0 was a y, it would be y is less than or equal to, right? That means from my vertex, I would go down. So even though I don't have a plus technically on my number line, you still have to analyze it to know that it's shaded in the middle. Okay, so your double solutions you're going to have to be careful with. Alright, so we answered it opens down. Now if I put crosses at -2, 0, is that correct? It doesn't actually cross it. So it bounces off the x-axis at negative 2, 0. It's a solid boundary. This is where we had to analyze, and it was shaded in the middle. Or you could say inside. Now, what would my interval be? Is it a range of numbers? If all I had was one critical value. Nothing was shaded, but this has a closed circle. So it's equal to negative 2. So that's all I have. Now what if my inequality was less than? I'd be shading where? The negatives. What would my inequality, not my inequality, what would my interval notation be then? All real numbers except x equals negative 2. Or, so that would be your set builder notation. So interval notation would be negative infinity to negative 2 parentheses, right? Because all I said was less than. I didn't say less than or equal to. So parentheses, union, another parentheses, negative 2 to positive infinity. Okay? So some of these you might have to really think about. Okay, do we have questions? Okay, your quiz, next class will cover 4.5 and 4.6.